Hey everyone, the review for Unit 6 is going to be split into two videos. We're going to cover the first half of the questions in this video and the next half of the questions in the next video. There's 20-something questions, so I don't want to do them all in one long video, so we'll split it up. So with that said, let's go ahead and get started with question number 1. Question number 1 gives you a quadratic in just some random form, 4 plus 3x squared minus 7x equals 0. And in part A, it's asking for you to write it in standard form. So standard form just means that the highest exponent must go first and then in descending order. So it would be 3x squared minus 7x plus 4 equals 0. So that was pretty straightforward. For part B, it's just asked for what is the value of A. A is the coefficient in front of the x squared. It's not this whole term. It's just the number in front of x squared. So A is 3. And then for question C, it says, what is the value of B? Again, B is the coefficient. It's not the whole term. So B is negative 7. And then for D, it's asking for the C value. C value is your constant at the end. So C is 4. We, of course, use that for the quadratic formula and other attributes when it comes to factoring and things like that. So that's the answers to number 1. Pretty straightforward. Number 2, it asks us to solve this equation by factoring. So we have 7x squared minus 5x equals x squared minus 6x plus 15. So if you remember, solving by factoring means you need to move everything over to one side so it equals 0, and then we have to factor from there. So we're going to subtract everything over here, or add everything, whatever you want, however you want to say that, over to this side. So subtract x squared, we end up with 6x squared. We're going to add 6x, so we end up with plus x. We're going to subtract 15, so we get minus 15. And then that will be equal to 0. If you wanted to move everything over to this side, you could. The problem with that is, it'll still work, it just makes it more difficult because now the a value would be negative. So anyways, from here we're going to factor. So remember, what goes on top is a times c. 6 times negative 15 is negative 90. And then the b value is 1. So what multiplies the 90 and adds to 1? Well, we can list all our factors. That's 1 and 90, 2 and 45, 3 and 30. Let's see, 3 and 30, 4 doesn't work, 5 works, 5 and 18, 6 and 15 will work, 7 doesn't work, 8 doesn't work, 9 works, 9 times 10. So those are all your factors. The one that adds up to 1 is going to be your 9 and your 10. Because I want a positive one, the 10 has to be positive. So there are the two factors in this group. Now we have to rewrite this by grouping. So that'd be 6x squared minus 9x plus 10x minus 15 equals 0. And then we'll group this. So the greatest common factor out of that is 3x. Sorry, that should say 6x squared. I don't know where I got the 6 from. So that'd be 3x times 2x minus 3. The greatest common factor here is going to be 5. And it'll be a positive 5. Remember to put a sign there, whether it's positive or negative. If you don't, then you're saying that all of this times 5, and we don't want to do that. So it's 5 times 2x minus 3, and then equals 0. Now we can see that this term and this term have a 2x minus 3 as a common factor. And then after I factor that out, I'm left with 3x plus 5. And then we set it equal to 0. So right now we've just factored it. The next step is to solve it. So we are looking for the x values for which this equation is equal to 0. So we will set each of these terms by the zero product property. We will set each of these factors equal to 0 and solve each of those. So we'll subtract 5 and then divide by 3. So x equals negative 5 thirds. And then we'll add 3. So we get 2x equals 3. And we'll divide by 2. So x equals 3 over 2. So our two answers are negative 5 thirds and 3 over 2. Okay, just a side note. Again, we need to make sure when we're factoring, these are our factors. The 3x plus 5 and the 2x minus 3 are our factors. When we are solving, the solutions are when x equals something. Now, just to go back in time, we were solving this equation. So we move things over so it's equal to 0, but a very important thing to note is this equation the same as this equation? And the answer is no, they are not the same equation. They are different. This is like a parabola, this side is like a parabola, and this side is like a parabola. When we set two parabolas equal to each other, what we're really asking for is where do those two parabolas intersect each other? We'll talk about that more in future units. But we are looking for where the two parabolas intersect, essentially. When we move everything over, now we're saying we have a single parabola, and we're looking for when the solutions, or when this parabola crosses through the x-axis. That's what that means. So these equations mean two totally different things. But the solution to this guy is going to be the same as the solution to this guy. So where these two parabolas here intersect, we'll have the same x values as when this parabola equals 0. So we work with this parabola to find out where it equals 0. And then we extrapolate. We say from there, since these are the solutions of this, it must also be the solutions of that. Anyways, that's just a side note. Let's move on to question number 3. So question number 3, it gives us x minus 5 squared, x minus 3 squared, if I could read, plus 5 equals 15, and asks us to solve. Now, it doesn't give us direction on how to solve this, so we could solve it by factoring, quadratic formula, completing the square. There's lots of different ways, but the way it's set up kind of indicates the easiest way of factoring it. So we're going to solve this by completing the square because, or not completing the square, but just by the square root method, which is kind of a result of completing the square, because we already have the x, just an x. There's no x squared or anything like that. So if you expanded this and said x minus 3 times x minus 3, then you're getting x squared minus 6x plus 9, and you're making it actually more complicated that way. It's doable, and there's nothing wrong with it. It just makes more efficient sense to be solving it just by isolating x. So when we subtract 5, we get 10. And then from here, we're going to go ahead and square root both sides because we are squaring a whole term. And to get rid of squaring a whole term is we square root. So what's left over on this side is x minus 3. And on this side, well, the square root of 10, we're going to leave it in radical form. But remember, anytime you take the square root, it's going to be plus or minus your answer. So we're going to say plus or minus rad 10. And then we're going to add 3 to both sides. So we end up with x equals 3 plus or minus rad 10. So this is an indication. If you were to go to solve this by factoring, it wouldn't have factored because you have a radical in the answer. So you would have had to use the quadratic formula if you were going to expand this out and put it in standard form. So that answer was C there on the review. Number 4, we have 3x squared minus 48 equals 0. Now you can solve this by any number of ways. You can solve by factoring, but because this is just an x squared, I'm going to solve by isolating x. I'll go ahead and do it 2 different ways so you guys can see it. But the first way, I'm just going to isolate x. So we're going to add 48 to both sides. So we end up with 3x squared equals 48. And then we'll divide by 3. So our goal is to get x squared by itself first. So x squared is going to equal 16. And then we're going to go ahead and square root both sides. And again, when we square root, we have to say plus or minus 4 because we actually have, most of the time, we have 2 solutions to a quadratic equation here. And so if we just put 4, that's only one solution. It's plus or minus 4. So that is the answer by just isolating x, the square root method. Let's go and solve it by factoring. Well, if I look at these 2 terms, I could just take out a GCF. The greatest common factor is 3 here. So I could say 3 times x squared minus 16 equals 0. And then I can keep factoring this. You guys should recognize this as a difference of squares. So this factors to x minus 4 times x plus 4. Okay, difference of squares, that's something you're going to want to know. And then from here we can use the zero product property. Well, remember the zero product property said if you're multiplying terms and the result is 0, that means one of those terms has to equal 0. So we set each one of those terms equal to 0. In this case, we have 3 different terms. So we're going to set 3 equal to 0, we're going to set x minus 4 equal to 0, and we're going to set x plus 4 equal to 0, and we're going to solve each one. Well, I know you're probably thinking, why would you even put 3 equals 0? Because that is a term that could equal 0 for this equation to be true. Now, obviously, this isn't true. 3 cannot equal 0, so there is no solution that comes from that. We would add 4 to both sides here, so we get x equals 4. And we subtract 4 from both sides there, so we get x equals negative 4. So you can see the solutions are the same either way that you do it. But this method is far more work than just isolating x. Sometimes you can't only isolate x, though, and that's why we have the factoring method. Okay, for number 5, we're given this equation 0 equals negative x squared plus 6x plus 6. And it says to find the roots of the equation. Another way to say find the roots is just solve for x. Show your work by completing the square and by the quadratic formula. So there's two methods I want you to use here. The first method is completing the square. So if you remember, completing the square requires us to have a and b, but no c value. So we're going to move the 6 over here, and we're going to say negative 6 equals negative x squared plus 6x. And we like having an a value of just 1. So we're going to go ahead and divide both sides by negative 1 here. So we get 6 equals x squared minus 6x. From there, we need to complete this square. So we showed the work before. Remember, when we do this x thing, it's a times c on top. Since we don't know what a c value is, that's our goal, is to figure out what c is here. We don't know what goes up here. But we do know that the b value down here is negative 6. Now, because this is a square, a perfect square, that means these two terms have to be the same. So what two values will add up to negative 6 that are the same? And that would be negative 3 and negative 3. From there, we can figure out what goes up here. Negative 3 times negative 3 is 9. And so that tells us what a times c is. Well, since we know what a is 1, we always want a to be 1 when we're completing the square. Since a is 1, we know that c is 9. So I'm going to, based on that little bit of work, I'm going to go ahead and add 9 to both sides of this equation. So we end up with 15 equals x squared minus 6x plus 9. Then from there, we'll go ahead and factor this. We've already done the work in factoring because the a value is 1. We see that these values are actually part of our factors. So we can say 15 equals x minus 3 times x minus 3. But again, our goal is to make it a square. So it's going to say 15 equals x minus 3 squared. And then from there, we solve it by the square root method. So we'll square root both sides. We end up with, again, when we square root, we get plus or minus the square root of 15 equals x minus 3. And then we'll add 3 to both sides. We can't add 3 to the 15 because that's in the radical. So we'll just say 3 plus or minus rad 15 equals x. And that is our solution using completing the square. Okay, so that's one method. You do need to know how to complete the square and solve by it. On the test, I expect you to be able to express all different methods, so don't stick to one method throughout the entire test. Make sure you are solving using all different methods, maybe the most efficient method for each problem, because I want you to represent all different methods. You need to know all of them. Now, for the quadratic formula method, I think I'm going to run out of room here, but remember the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And so we'll plug in our values here. So I'm going to list them. A equals, back from the original, a equals negative 1, b equals 6, and c equals 6. So this will say x equals negative b, so negative 6. Notice I put parentheses around that. It's always good practice. B squared, so that'll say 6 squared, minus 4 times a is negative 1, and then c is 6, okay? And then all over 2a, so 2 times negative 1. From here, we'll simplify. The method of simplification is the same for all quadratic formula methods, so we're going to simplify that negative b, so that'll say negative 6 plus or minus the square root of 6 times 6 is 36. Then we're going to multiply all of these. Negative 4 times negative 1 times 6 is positive 24. And then divided by negative 2. Then we can go a little bit further. We can say negative 6 plus or minus the square root of 60 over negative 2. We're going to simplify that radical. Not going to dwell a long time on simplifying that radical. That radical simplifies to 2 rad 15 over negative 2. And then we reduce that from here. So we say x equals negative 6 divided by negative 2 is 3. And then 2 rad 15 divided by negative 2 is rad 15. Now I want to talk about the signs here for a second. This is plus or minus. So if I say a positive divided by a negative, we get a negative. If this was a negative, then it would be a negative divided by a negative, which is a positive. So because this is plus or minus, when I'm dividing by any sign value, it will still end up being a plus or a minus. It'll still end up being positive or negative. So we can just carry that down no matter what that is. So our answer is 3 plus or minus rad 15, which is exactly what I got in the original there. Okay, so that was the answer to number 5. I guess you'd say D on the multiple choice options. Okay, for number 6, it just says solve. So we've got x squared minus 8x equals 48, and we just solve it. Now, in my mind, this case, because I see that the a value is 1, and because it's multiple choice, is kind of unfair. I see all the answers are whole numbers. I like factoring in this case. So I'm going to get everything equal to 0. So we'll say x squared minus 8x minus 48 equals 0. And then we'll factor that. This should be pretty easy factoring by now. Because the a value is 1, we know this is going to be x and x. We are looking for something that multiplies to 48 and adds to 8. So that's going to be 4 and 12. And because I want it to be a negative 48, one of these has to be negative. Because I want it to add to negative 8, the bigger one has to be negative. So those are my factors there. If you didn't see that, then you would just factor. A times c is negative 48. B is negative 8. We list our factors. 1 times 48. 2 times 24. What is that? 3 times 16. 4 times 12. 6 times 8. And that's all of them there. We were looking for the one that adds up to 8. So that's this guy. 4 and 12. The 12 is negative. So there's that. We do not have to group because the a value is 1. So from here, we do the zero product property. So we say x plus 4 equals 0 and x minus 12 equals 0. Solve each one of those. So x equals negative 4 and x equals 12. And those are our solutions. Negative 4 and 12. Okay, so that's for number 6. For number 7 is probably one that if you did this early, which you should have done, you probably got hung up on based on the verbiage. Number 7, it says the average of two numbers is 11, and the product of two numbers, product of the same two numbers, is 117. So we have to know what these two terms mean, average and product. Well, remember average, how do you find average? Another word for average is mean. You add up the terms and you divide it by how many terms you have. Because we're just looking for the average of two numbers, we only have two numbers. So how do I take the average? I add up the two numbers. I'm going to call them A and B. So I'm going to add A plus B, and I'm going to divide it by how many I have. I have two numbers. So the average is equal to 11. Add up the numbers, divide by how many you have. The product of the same two numbers is 117. Well, remember, product means multiplication. So we're going to multiply the two numbers, and we get 117. So now I have two equations, and I have two variables. I have to figure out a way to solve that system of equation is essentially what it is. Because I've got two equations with two variables. I can't solve by elimination because I don't have the same operation going on here. So the best way to solve this is by substitution. So I need to isolate a variable here. And the easiest way to isolate is to deal with this guy because there's a sum here, not multiplication. So I'm going to go ahead and multiply both sides by 2. I end up with a plus b equals 22. And then I'm going to isolate one of the variables. I'll go ahead and isolate a. So I end up with a equals 22 minus b because I subtracted b from both sides. Now I can use substitution. Anywhere there's an a value, I can substitute this 22 minus b. So this equation is now going to read 22 minus b for a times b equals 117. And then we can solve this equation. In this particular problem, it said to solve using the quadratic formula. So quadratic formula means I got to get it into standard form. So I'm going to distribute the b. I end up with 22b minus b squared equals 117. And then I got to get everything over to one side so it's equal to 0. I like my a values to be positive, so I'm going to move both of these guys over here. So it'll say 0 equals b squared minus 22b plus 117. And then I'm going to use a quadratic formula from there. So it would be x equals negative b. I know I got b here. Maybe I should have used a different letter here. But the b value, or the coefficient in front of the term with a single exponent, is negative 22. So it'll be negative 22 plus or minus the square root of b squared. So it'll be negative 22 squared minus 4 times a is 1, and then times c is 117. and then all over 2 times 1. And then we just simplify it from here. So that'll end up being positive 22, negative 22. 22 squared, what is 22 squared? 22 squared is 484. And then 4 times 1 times 117 is negative 400. And what do we have here? Negative 468. And then all over 2. So x equals 22 plus or minus the square root of 484 minus 468 is going to end up being 16. And then we'll divide by 2. So we can simplify this. This turns into a nice clean whole number. It'd be 22 plus or minus 4 over 2. And then we can solve each one of those, or we can divide each one of those. I like simplifying it this way. 22 divided by 2 is 11. 4 divided by 2 is 2. So we could say 11 plus or minus 2. And as a result, we end up with 11 minus 2 is 9, and 11 plus 2 is 13. So technically, I shouldn't have used x. The term I was solving for was b, so we'd say b equals this value. Okay, b equals this. Because I labeled these values a and b, I should have maybe called them x and y. But anyways, that's the two possible values for x, for b. And now I need to find the value of a. Well, I'll use this equation because this is the easiest one to work with. I'll plug b value in, so I end up with a equals 22 minus 9. So a equals 13. And then the other one would be a equals 22 minus 13. So we end up with a equals 9. So in this case, the a and the b value are just the same values that I got here. So we could either say that a is 9 and b is 13, or a is 13 and b is 9. But either way, we need to answer the question from there. It says, what is the value of the larger number? So if this is my setup, the larger number is 13. If this is my setup, the larger number is 13. So the larger number is 13. We can check our work by plugging these values back in, 9 and 13. 9 plus 13 is 22, divided by 2 is 11, so it looks good there. And then 9 times 13 is 117, so we know we did it right. Okay, so that's for number 7. Okay, let's go ahead and take a look at number 8. Number 8, it says, what equation has no real solutions? No real solutions. So we have a bunch of options here. And if you remember, the only way to determine if it has real solutions or not is by the quadratic formula, or at least a part of it. It's the discriminant part. So real solutions implies the square root of a positive number or the square root of 0. Non-real solutions, or imaginary or complex solutions, are a result of the square root of a negative number. So what we need to do is figure out what the conjugate is for each one of these terms, or each one of these equations. For option A, it says x squared minus 8 equals negative 4. Well, this one's actually pretty easy to see without doing any work. I'll just use the square root method. We get x squared equals 4. And then when I go to square root this guy, you can see that the square root of a positive number is a real number. So A has real solutions. So A is not the answer because we're looking for the one that has no real solutions. For option B, it gives us x times x minus 3 squared equals 5. Again, we could get this down to standard form and find the discriminant. But because this is already in a factored form, it's probably easiest to solve for x and to see what's going on here. So I'm going to isolate the square root, so I'm going to divide by 6. So I end up with x minus 3 squared equals 5/6, whatever that is. And then when I go to solve this, when I square root the 5/6, that's a positive number, so therefore it's going to produce real solutions. So B has all real solutions here. For C, same thing going on. We've got x plus 4 squared plus 5 equals 2. And then we're going to isolate the squared expression. So we're going to subtract 5 from both sides. So we end up with x plus 4 squared equals negative 3. We'll square root both sides. And we see right here that the square root of a negative number is not real, it's imaginary. And so as a result of this, C does not have any real solutions here. Okay? Now, I do want to look at option D, because I believe option D does express, well, it doesn't express, I thought it did, but we'll go ahead and look at it anyways. This one might be a little deceiving because we see a bunch of negatives in there. So I can just isolate x squared if I wanted to. I'm going to subtract 7. So I end up with negative 4x equals negative 16. And some of you might be going, well, that's a problem because there's x squared and I've got a negative. But remember, we've got to get rid of that a value first if we're just solving by isolating x. So we're going to divide by negative 4. We end up with x squared equals positive 4. And again, when I go to square root, the square root of a positive number is real. So therefore, that produces 2 real solutions. So our only option, or our only answer here is C. Okay, let's see here. For number 9, let's see what we got going on here. For number 9, it says solve the equation below. So this is just all about solving equations. This whole test, it seems like. 6x squared plus 5 equals 18. Well, because I only have a singular term that has an x value in it, then factoring in the quadratic formula is not the best way to go. The best way to go, if you have just x squared or just x, is to isolate x like you did in Math 1. So we're going to subtract 5 from both sides. And so we end up with 6x squared equals 13. We're going to divide by 6. So we end up with x squared equals 13 over 6. And then we're going to go ahead and square root both sides. Now, I agree that this is a gross answer, but the final answer is x equals plus or minus the square root of 13 over 6. Now, that's not a form that we normally deal with. So we need to rewrite it in a way where there is no radical on the bottom and there might be a radical on top. Well, we need to realize that this actually means x equals the plus or minus of the square root of 13 over the square root of 6. That's what this means. Okay. From here, we need to rationalize the denominator. So we're going to go ahead and multiply by rad 6 over rad 6. And then solve it from there. So x equals plus or minus rad 13 times rad 6 is rad 78 over 6. And then if we can simplify the radical, we would. The factors of 78 are 13 and 6. That's how we got it. And then 13 is prime. 6 can factor to 2 times 3. But regardless, we end up with 2 times 3 times 13 inside the radical. There are no pairs, so there are no perfect roots, so we can't simplify this any further than it already is. If this was a calculator problem, then we would just convert it to decimal form. But that is your answer for this problem. For number 10, what is the discriminant for the quadratic equation? So we've got 0 equals 4x squared plus 12x plus 8. And we're asking for the discriminant. Well, in order to find the discriminant, we have to have the equation written in standard form and equal to 0. And if you remember, the discriminant is the radical part of the quadratic formula here. So this guy is our discriminant. And why do they call it the discriminant? It's because it discriminates between real solutions and complex solutions. If the discriminant is the radical of a positive, then it's going to be real solutions. If the discriminant is the radical of a negative, then it's going to be complex solutions. So all we want is the discriminant here. So we would say the discriminant, and some would argue that the discriminant is just the b squared minus 4ac. It doesn't really matter. I like the radical on the outside of it because it emphasizes the fact that you're taking the square root of a positive or a negative. So we're going to say that the discriminant is the square root of b squared, so that's 12 squared, minus 4 times a, which is 4, and then times c. So this is the discriminant here. 12 squared is 144. Let's see. 4 times 4 is 16 times 8. 16 times 8 is 80 and 48, so that's 128, so minus 128. And then from here we simplify that. We've got radical 16 here. And then we'd say the discriminant is 4 if you're including the radical on that. And then because this is the square root of a positive number, we have real solutions. It wasn't asking for that, but we would say that the answer is 4. Okay. For number 11. Number 11, it says, what are the coordinates of the x-intercepts of this equation? So, or this function, y equals x squared plus 4x minus 21. So all the review problems so far have been focusing on just solving equations. And I want to make sure that you understand that there's a difference in terms of what I'm asking for when I say solve an equation and then find the x-intercepts. The process is very similar, but make sure you understand the difference between what it means, what's actually happening. So we are looking for x-intercepts here. And so we have to know what an x-intercept is. Well, the x-intercept is where the graph crosses the x-axis. So we could say here and here are your x-intercepts. Well, how do we find x-intercepts? Both cases, no matter what, x-intercepts will always have a y value of 0. Whatever these x values are, the y value will always be 0. So that's exactly how you solve it. We find when y is equal to 0. So I'm going to go ahead and write that down. X-intercepts are when y equals 0. So we're just going to set y equal to 0 here. So it'll say 0 equals x squared plus 4x minus 21. Now from here it's just solving. We've done lots of that. I like the factoring method in this case. So it's going to be x and x, and it will be 7 and 3 because what multiplies to 21 and adds to 4. And because I want a positive 4, that'll be positive. And because I want it to multiply to negative, one of these has to be negative, so that's that there. And then we use a zero product property here, so we say 0 equals x plus 7, and 0 equals x minus 3. And then we solve each one of these cases, so x equals negative 7 and x equals 3. Now, if this was just solve the equation, here, we'd be done. But because it says find the x-intercepts of this guy, we need to write these as an actual coordinate. X-intercepts are coordinates. So the coordinate of the x-intercept are negative 7, 0, and 3, 0. Those are my x-intercepts. If you leave it like this, technically you're wrong. So be careful with your notation there. Okay? For number 12, it says, what is the solution to the equation? This one looks a little bit gross. 2 times x minus 3 squared minus 5 equals 13. Now later on in future units, we're going to be talking about the vertex form. So here, this is the vertex form, actually. But we're going to go ahead and isolate x here. We have a singular x. It's already a factored form in a sense. So I can isolate x without doing the quadratic formula or factoring. So I'm going to get the term squared by itself. So the first thing I'm going to do is add 5 to both sides. So I end up with 2 times x minus 3 squared equals 18. And then I'm going to divide both sides by 2. So I end up with x minus 3 squared equals 9. And then I'm going to square root both sides because I have something squared. And to get rid of that, we square root. So we end up with x minus 3 equals plus or minus 3. And then from here, we're going to add 3 to both sides. And so we have to look at each individual case here. So a positive 3 plus 3 is 6. And a negative 3 plus 3 is 0. So we could say x is equal to 0 or 6. So C is our answer for number 12. All right. Let's look at number 13 here. Number 13, it says consider the equation 6x squared minus 2x plus 5 equals 0. And it says, what is the nature of the solution to this equation? And it says there is no solutions because there are two imaginary solutions because there are two real solutions because there are two imaginary solutions because. So it's prompting you with a multiple choice, but you guys should be able to determine. I should have maybe written the question a little differently. How many solutions does this equation have, and what type of solutions are they? So we can figure that out by the discriminant. So we just need to find the discriminant. So the discriminant is square root of b squared minus 4ac. So we'd end up with the square root of negative 2 squared minus 4 times 6 times 5. And then we'd simplify it from there. So we get the square root of 4 minus 120. 4 times 6 is 30 times 5. Sorry, 4 times 6 is 24 times 5 is 120. And then from here we end up with the square root of negative 116. Well, because we're taking the square root of a negative number, we would say that there is no real solution to this. There's only an imaginary solution or a complex solution. So we would say that there are two complex solutions since the discriminant is negative. Oh, I guess I got to correct myself here. The discriminant is the value inside. So it is just the b squared minus 4ac because the discriminant is negative. Number 14, it's saying solve by completing the square. So we have x squared plus 3x minus 3 equals 2x squared plus 7x minus 1. Now it says solve by completing the square. Remember, completing the square implies that you have an a term and a b term, and you're trying to figure out the c term. So I want to move all the x squared values over to one side. I want to move all the x values over to one side, and I want to move all the constants over to the other. So I'm going to go ahead, all in one swipe here, I'm going to go ahead and subtract x squared from both sides. I'm going to subtract 3x from both sides, and then I'm going to add 1 to both sides. So when I do that, these guys cancel out, these guys cancel out, and then negative 3 plus 1 is negative 2. 2x squared minus x squared is x squared. 7x minus 3x is 4x. And then the negative 1 plus 1 is 0. So now I have it in a form where I can complete the square. So our goal is to figure out what this value is here in order for us to complete the square. So we're going to do our little x thing over here. Remember, a times c goes on top. I don't know what c is, so I can't fill that in yet. B goes on the bottom. The b value is 4. And because we're completing the square, these two terms have to be the same. So what two values add up to 4? That'd be 2 and 2. And now because that's 2 and 2, I multiply those together to get this value. So remember, this is a times c, and this is b. Since a times c is 4, and the a value is 1, we can deduce that c must be 4 because 1 times what gives you 4. So we can conclude here that c is 4. So that implies that we're going to add 4 to the right-hand side. Well, if you do that, you have to do the same thing to the other side. So we're going to add 4 to that side. So 4 plus negative 2 is 2. And then on this side, we end up with x squared plus 4x plus 4. Then when we go to factor this, our work is already done. So factoring this, because the a value is 1, is these terms. So it's going to be x plus 2 times x plus 2. You can kind of skip that step and just say 2 equals x plus 2 squared. And then from there, you solve it. And that's what it wants us to do, is to solve. So we've completed the square. We're going to go ahead and square root both sides. So the square root of 2, remember, plus or minus square root of 2 equals x plus 2. And then we're going to go ahead and subtract 2 from both sides. These are not like terms, so they can't go together. So we'll just write this as negative 2 plus or minus the square root of 2 equals x. And that is our solution. So that would be option B there. Okay. All right, that's number 14. Number 15, let's see, number 15, it says, use the quadratic formula to solve this equation, 9x squared minus 24x equals negative 16. We're using the quadratic formula, so to do that we have to get everything over to one side, so it says equals 0. I would prefer to move everything over here because that keeps our a value positive. So we'd end up with 9x squared minus 24x plus 16 equals 0. Now we've got some big numbers here, and there's nothing that we can really reduce out of this, so we're just going to use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Anyways, so x equals negative, well, maybe we should do this. Let's figure out what a, b, and c are. A is equal to 9, b is equal to negative 24, and c is equal to 16. So negative b, that'd be negative 24, plus or minus the square root of b squared, so that'd be negative 24 squared, minus 4 times 9 times 16, and that would be all over 2 times 9. Now from here, I think we have some calculator work to do. Negative 4 is 24, plus or minus the square root of, 24 squared. 24 squared, let's see. I'll just do it off to the side here. 24 times 24, 16, 96, 8, 480, so 6, 7, 576. So you get 576 for that term. And then 4 times 9 is 36, and times 16, so that's 6 times 6, 36, 18, 21, 0, 6, and 3. So that's 6, 7, 576. So it'll be minus 576. Oh, look at that. That does clean up quite nicely. All over 18. And then from there we can solve it. So we get 24 plus or minus, well, 576 minus 576 is 0. So the square root of 0 is 0. So we end up with 24 plus or minus 0. Doesn't change anything, over 18. That can be reduced by a factor of 6. So we end up with 4 over 3. So we only get one solution here. One solution. And this was number 15. So our answer is C. Again, just thinking through logically. If the discriminant is positive, you're going to get two real solutions. If the discriminant is negative, you're going to get two imaginary or complex solutions. And if the discriminant is 0, well, the square root of 0 is 0. It's not plus or minus. You only deal with the idea of 0 approaching 0 from a positive or a negative side when you get to calculus. So the square root of 0 is just 0. So you only get one real solution here. Okay, so that's number 15. We're going to do one more for this video. Number 16. Number 16, it says, what is the order of the equations from fewest to most real solutions? So here we've got 4x equals x squared plus 4. We've got 5, here, let me leave some room here. 5x squared plus 7x equals 12. And then we have x squared plus x equals negative 5. So we're trying to order these from fewest to most real solutions. Well, logically, you can either have two real solutions, one real solution, or two imaginary solutions, which means you have 0 real solutions. So one of these is going to have no real solutions, and then one will have 1, one will have 2. And again, the way we figure that out is by the discriminant. So we want to get this equal to 0, so it'll say 0 equals x squared minus 4x plus 4. We do the discriminant, so that'll be it'll be b squared, so negative 4 squared minus 4 times 1 times 4. And then we simplify that. That would be 16 minus 16, which is 0, square root of 0. So this guy has one real solution. Okay. For this guy, we're going to subtract 12 from both sides, so 5x squared plus 7x minus 12 equals 0. We apply the discriminant, so we end up with 7 squared minus 4 times 5 times negative 12. So we end up with the square root of 49. And then really it doesn't matter what this is. 5 times 12 is 60. 60 times 4 is 240. but a negative times a positive times a negative is a positive. It didn't matter what those values were, because the end result of this discriminant is the square root of 289, but really all that matters is positive. So as a result of that, we have two real solutions for the second option. And then for the last option, we get x squared plus x plus 5 equals 0. Apply the discriminant, so it'll be 1 squared minus 4 times 1 times 5. Simplify that, we end up with the square root of 1 minus 20, which is the square root of negative 19. Since the discriminant is negative, we have 0 real solutions and 2 imaginary solutions. So in order from the least or the fewest number of real solutions to the greatest, it would be x squared plus x equals negative 5, and then it would go to the 4x equals x squared plus 4, and then it would go to the 5x squared plus 7x equals 12. That means A is our answer there. All right, so there's basically the first half of this review. Stick around for the next half, the next video, so that you are fully prepared for the test.